Good evening, everyone. I hope everyone had a good Easter weekend if you celebrate. I'll start off the presentation by apologizing in advance. Currently house sitting for two giant German shepherds, so if there's any barking or boofing, I completely apologize. But a little bit about my research. The research I'm looking to investigate is the effects of strength training on performance in adolescent track and field athletes and throwing events. So I actually, for the past 3 years, have been working as a coach and athletic trainer for a local school. I coach specifically the throws events, and I've was a thrower myself for about 6 years. So it's interesting to see what types of exercises work best for this age group, specifically, especially since I'm working with them directly. A little bit about my methodology and introduction to it. An introduction to this chapter. This chapter aims to assess and prepare data collection methodology for improved performance in adolescents. The age group I'm working with is 13 to 18 years of age. Our varsity program and the sample pool that I'm working with has kids from 7th grade all the way up till 12th grade. So it's a pretty big sample population of about 20 athletes who compete in the throws events. So the throws events, for those of you that might not know track and field, includes the shot put, the discus, and the weight throw. Primarily, I'm going to be investigating the shot put and the discus at this time. In varsity track and field, we're going to use multiple methods in this data collection, such as two-way, ANOVA correlations, as well as the Pearson correlation, vertical jump testing, and 1 repetition max testing. The sample pool will be about 20 athletes within the age range with a mix of both female and male athletes, which identify as those genders. A little bit more about the methodology specifically. For those of you that don't know, two-way ANOVA is a statistical test that analyzes the difference between the means of more than two groups. So we're going to be looking at the groups of not only male and female throwers, but throwers that might just be competing in shot put and throwers that might just be competing in discus. So it's really a combination of 4 different groups that we're going to be investigating. We're going to use it to estimate how the mean of quantitative variable changes according to levels of two categorical variables, which will be throwing distance and the weight training program, how much weight and how much strength they have built throughout the program, and the investigation in total. Pearson correlation is a coefficient often represented by the variable R. It is a statistical measurement between two continuous variables and helps to quantify the strength and direction and relationship. So the range is from -1 to +1, with a value of 0 indicating that there is no linear relationship, and while -1 and +1 indicate perfect negative or positive correlations. My prediction and what the data I've collected so far has shown is that there seems to be a positive correlation between the amount of weight a thrower is able to lift and their throwing distance. That's not always the case. There are outliers on the team. Some of the young athletes I work with are able to really generate a lot of strength in their lifts and not a lot of explosive power at the same time. So that would show possibly a perfect negative between their vertical jump testing and their strength testing, but we'll get to that once the time comes. The vertical jump test is one of the methods that we're going to use to collect the data. So it's most commonly used to measure an individual's lower body power, and we do this by measuring the distance they can jump vertically. It involves measuring the height of the individual's standing reach and then measuring their highest point reached during a stationary non-dynamic jump. So what I mean by that is they're just in the squat position, they're lowering themselves, and they're jumping straight up like a tuck jump almost, or a rocket jump. They don't have any steps prior to their jump, so it's just pure power that is being generated in that moment. We take the difference of these two heights and these two measures, and it indicates the vertical jump capacity. So for instance, if their standing reach was 20 inches and they were only able to jump 30 inches total, then they had a vertical jump of 10 inches. Another means that we're going to use to measure is 1 repetition max. This is known as the heaviest weight an individual can lift for a single repetition of a given exercise. It is a key measure of muscular strength and is often used for strength training programs to help guide intensity. So the 2 1 repetition max exercises that we will be investigating will be the traditional barbell squat as well as the traditional bench press. And we already use this in our training program prior to this investigation to see how much an individual can lift. So we usually at the beginning of the season for our preseason data collection or baseline testing, we do 1 repetition maxes so that we can figure out how much the individual could lift. For example, if they can only lift 100 pounds in bench press and we want to do 80% for their lift for 5 repetitions, then they would be doing 80 pounds for those 5 repetitions. The instruments to be used are an electronic timing system. For example, Bauer timing, utilized to measure explosive power and reaction times. During the strength training, we want to see how quickly they can move the weight and how explosively they can move the weight, how much time it takes them to move it from concentric to eccentric phase during their lift. We're going to be using throwing implements, all standardized. Shot put, discus, weight bag, primarily the shot put and the discus. They're standardized throwing implements for each gender. So 8 pounds for women or 4K and 12 pounds for men or 6K. And they are used to ensure consistency in all measures for various sport-specific progress and to see how the training is working in a real-world setting. We'll also be using a dynamometer, which is we're going to be using a handheld version to measure grip strength, which will serve as a proxy for overall muscle development, and we'll see how strong they are through that. We're also going to be doing questionnaires and surveys. So we're going to be doing a physiological readiness for sports scale survey prior to the lifts and the programs, just to see how the young athletes feel about the lift, how they feel going into it, if they feel like they're ready to move this way, if they feel like they're ready to perform these lifts to their absolute best. We're also going to be using training logs to provide pre-programmed perceived levels of readiness as well as perceived levels of exertion. We can also track the amount that they are lifting week by week and session by session through this and compare it through different scales. And then we're going to be using statistical analysis software, which will just be used to compile the data for constructing the two-way ANOVA and the Pearson correlation as well through all of these lifts. Procedure will be pretty straightforward. Participants were recruited from a local high school varsity track and field program with athletes varying again from 13 to 18 years of age. Informed consent was given to both the athletes and their respective guardians. We did perform baseline assessments for throwing distance, explosive power, and strength measurements were conducted prior to the program participation. The program will include 1 compound exercise per workout. Compound exercise, for those of you that may not know, is one that activates multiple muscle groups. So for the 1 rep max that we're looking at, the compound exercises would be the squat will stay on the program, and then the bench press will stay on the program throughout the whole entire cycle. It will also include 3 to 4 auxiliary exercises with both strength-based exercises and plyometric work being implemented under the supervision of their coaches. For example, we will have a few auxiliaries on upper body day, such as bicep curl, tricep extension. Leg day will include such exercises as Bulgarian split squats, but will also include box jumps. So we're including different movements into the cycles as well. And post-training cycle measurements will be performed under the same regulations and standards as baseline assessments. That way we can keep everything consistent and in line, and there's no variables in terms of measurement. Data collection. All performance data will be recorded and collapsed for statistical analysis with the inclusion of the PRSS results from the baseline analysis. And for statistical analysis, it was performed using SPSS software to compare pre- and post-program key metrics. Paired sample t-tests were employed to assess differences in explosive power, throwing distance, and grip strength. Ethical considerations for this project include, but are not limited to, informed consent. So prior to participation, we had to get the consent obtained from all participants and their legal guardians, since they're all under the age of 18 for the most part. Even those that are that are 18, because it is in a high school setting, we still want the informed consent from their legal guardians. Detailed information regarding procedures, potential risks and benefits, and the right to withdraw at any time without penalty were discussed, and consent forms were distributed, signed, and discussed thoroughly. So the right to withdraw is a big one, especially being in the high school sports setting. You may have a kid that's trying track for the first time this year, and then they find out they don't like it, they quit immediately. But then our first week, we had one participant that was failing 4 classes, so he unfortunately was kicked off of the team for not being able to participate. So that was withdrawal early on in the program. Nothing you can do about that, unfortunately. So we actually weren't even able to collect data from him. We only got to collect informed consent. Next is a assent from participants. So we had to give age-appropriate explanations to all the athletes, make sure that they understood all the terminology that we're using, what this data is being used for. That way they can understand their involvement and their associated responsibilities, such as tracking their program, sticking to the program as it is written, as well as being consistent with their lifts. 3, safety and well-being. All training sessions were supervised by trained coaches. So training sessions were supervised by myself. I'm a certified strength and conditioning coach. I'm certified as a personal trainer and as an athletic trainer. The other coach that was supervising this project has been in the sport and training athletes for over 20 years. We were just there to make sure and supervise the lifts were done properly and safely and with proper form to avoid any sort of unnecessary injuries from the athletes. The 4th consideration is confidentiality. Has to be maintained due to them all being minors. It should be maintained regardless, but because they're minors, we have to take a little bit more care into it. We use unique ID codes for all the athletes in the data collection so that they were all vague. If somebody were to grab our laptops or my laptop and see, they would not know who is who or whose data is which. We like to keep it that way. I'm the only one with the codes, so that no one else can see them. Only accessible via myself. The 5th consideration is, again, the right to withdraw. The right for participant withdrawal was disclosed to all athletes, again, using the example of that young man or that young athlete that had to withdraw within the first week. Things happen. Kids are unpredictable. Anyone's unpredictable. If somebody wants to quit the team or quit the program, they have absolutely every single right to do so. They don't have to participate for the whole entire program consideration, which will be over the course of 12 weeks. Data handling, all data results were reported in aggregate form to avoid any identifying features. This directly correlates to confidentiality. They're both working hand in hand. We want to keep things private, keep their information safe, especially, again, with them being minors. And then number 7 will be obtaining IRB approval, which we all have to do at some point throughout our dissertation. That is a brief overview of my methodology. I look forward to hearing everyone else's. My reference sheet is right on the link right there. It's a completely accessible Google Docs. Feel free to look at it. Feel free to look at anything, and I look forward to hearing everyone's feedback.